Hi all, I'm Babu and welcome to my Hadoop developer demonstration. So before starting my demo, I would like to ask you a few questions. Of course, I'm going to answer for you. So what is this Hadoop and why is this Hadoop and how we are going to get benefited if we are going to learn this Hadoop course? Why Hadoop? Before going to ask this why Hadoop question, I would like to ask you one more question. What is big data? And why each and everyone is actually looking into big data. As you know, fellas, our era of computer system has started around at 1970s. That time, each and every organization has utilized RDBMS systems to store their business data. Why we are storing our business data? If we have our business data stored somewhere, that will help us to analyze the business, which will actually help us to take the better decisions. I can say best decisions because it is business. You cannot take approximate decisions in order to improve your business or to take. I mean, if you want to improve your business, of course, you have to take some decisions. To take those decisions, obviously, those decisions should not be approximate. They should be appropriate. How you can take decisions appropriate? When you have your data stored somewhere in the system, you can analyze the data and you can take the appropriate business decisions. Let's say I have my business running from 2000 and today is 2016. From past 15 years, if I can analyze my business, I can understand where the downfall is there. Let's say from 2000 to 2001, I have a little downfall. From 2001 to 2002, of course, my performance of the business is increased. From 2000 to 2003, it is kind of moderate. After 2003 to 2004, okay, let a little more improvement. 2012 to 2006, again downfall. So this is how my chart looks like. In that case, if I have the data where the downfall actually occurred or where business is kind of mute, I don't have any profits at the same time. I don't have any losses. The business is completely mute. If I'm going to get all the data extracted somewhere from the system, and if I can analyze why my business is actually in a downfall situation, why actually my business is in a mute situation, because I have entire data in front of me and I can analyze and I can find out and I can investigate where the root problem is, and I can try to at least overcome the cause, whatever makes my business downfall. So I can actually take care of that particular problem which caused in my recent years or previous years my business downfall, and I can actually take good decisions. At least I'll try to overcome the problems which I had faced in my earlier years. All this happens if you have the data. How you can actually store that kind of data? I told you from the era of 1970s, people started using RDBMS, but RDBMS has so many number of complexities. What are these complexities? First thing, you can store only relational database management system is nothing but you can store relational data, structured data. You can store unstructured data in your RDBMS systems. You can store unstructured data in your RDBMS systems. When you can't store the data, obviously you can't perform, you can't process the data. That's sure. So how you are going to take those two challenges which are not actually taken care by RDBMS systems? That's the problem we had. Again, coming to RDBMS system, if your data size is less than 1 petabyte or less than 1 terabyte, then your RDBMS system is so good to work with your data. I know every one of us know uh, how we are going to calculate our memory in bits, bytes, KBs, MBs, GBs, terabytes, petabytes. I don't know how many of us or how many of you are aware of this data calculations more than petabytes. If the data size is growing more than petabytes of scale, so these are the calculations which are actually existed in the market to calculate your data. If your data size is less than a terabyte, then your RDBMS engines are pretty suitable, and of course, it is a structured data. Those are pretty suitable to work with you. If your data size is growing terabyte, then what happens? That is the situation people have found uh, data warehousing. If your data is actually going to cross transactional data scale, they found a term called historical data, and they have started moving that kind of historical data into data warehousing. In data warehousing, if you have that RDBMS or that relational data, how you can actually organize that amount of data? If I said organizing that amount of data, we had two challenges. The first one is processing that much amount of data, and on top of processing, storing that much amount of data. If you can store that much amount of data, obviously later you can think of processing. So these two are the primary challenges industry is facing as of today. Of course, as of the first one. If you can organize that much amount of data, if the data is more than 1 terabyte, if the data is less than 1 petabyte, 1024 terabytes of data, 1 petabyte. If your data size is one less than 1 petabyte, then your data warehousing, whatever the technologies we are using, your ETL tools like your Informatica Ab Initio, or your reporting tools like Cognos or something like that, or any other intelligence tool like MSBI, whatever the technology you are using for your data warehousing, if the data size is less than 1 petabyte, then you can happily go with it. But if I'm an entrepreneur, end of the day, I will have to maintain my data irrespective of my data size. I'm going to maintain my data. Okay. I have to maintain my data. That's okay, double good. I'm an entrepreneur. I'm using data warehousing. So most of you might have aware of these softwares. So if I have to purchase an Informatica Enterprise license version, how much should I have to pay? That is lakhs and lakhs of rupees, probably crores of rupees. For ETL process, I'll do that. For reporting process, again you'll have to purchase Cognos or something like that, Enterprise license. Again, I'll have to invest crores of rupees. Once that is completed, I will have to do some kind of analysis, or I'll go with some data visualization tools such as your Tableau or Pentaho. There also, again, to purchase those licenses, you have to spend that much amount of data. That is there everywhere. So data visualization techniques are the end user techniques where business people are sitting in front of those systems and they can analyze the data. That is nothing like they can operate these Tableau or these kind of tools, but the reports or the whatever presentations we are going to export using those kind of data visualization techniques, so they are actually going to look at them because they don't know technical stuff. They know how to improve the business. They know only business kind of stuff. They are functional people. They are not technical people. But end of the day, if to maintain my data somewhere from software point of view, so like this Teradata or Informatica or Cognos or something else, I will have to invest crores and crores of rupees. I'm an entrepreneur. I always think to invest 1 rupee to get a profit of 10 rupees. Because I'm an entrepreneur, I will think in the same way. Practicality is different, but at least my expectation would be like that. I don't want to invest 9 rupees to get profit of 10 rupees, nothing but 1 rupee margin. I don't want like that because I'm an entrepreneur. Once again, I'm an entrepreneur. I always try to think to invest little to get more. So investment from software point of view has become kind of hurdle, has become kind of demon, a ghost for entrepreneurs to maintain that much amount of data. That too, we have so many complexities. Like if your data size is more than 1 petabyte, hands up. If you have unstructured data like or semi-structured data, to process that much amount of data, you will have to go through ETL. That much investment you made, even though to do your ETL, it is going to take so much amount of time to perform your ETL life cycle, it is going to take so much amount of time. Once that is completed, again to do reporting, that is going to take so much amount of time. Once that reporting is completed, end of the day, you are going to put your data in your visualization technologies. That is there. Your money is gone, your time is gone, still you have so many complexities. On top of all these things, from hardware point of view, every one of you know to install or to deploy these kinds of informatica kind of software or data warehousing technologies, you would need to use servers, high-end hardware. That is not like cheap-end hardware what we use for our laptops or our desktops. If you are going to use high-end hardware like servers, if I would like to use a machine with some 12 gig of RAM and 2 terabytes of hard disk and some 6 cores or 4 cores processor, I can hardly get in within 50,000. Okay. If I have to get that same configured machine with high-end infrastructure like servers, I'll have to invest in lakhs. So again, from entrepreneur point of view, from software wing, I have invested so much. From hardware wing, I have invested so much. Still, I am facing complexities. Still, I have so many issues. Then, what is the solution? How can I actually do it? Yeah, whenever your data size is actually growing more than petabytes of scale, then that thing we used to call as big data. Believe Google.com is producing 200 petabytes of data every day as per the statistics taken 2013. If they are producing that much amount of data every day, so how could be their total data as of today? I'll tell you one more. I have used computer system from 2006 or 5, I believe. 2005, I believe. So 2005 or 2004. So that time I have used P2 system. My RAM was 128 MB. My hard disk was 20 GB. As of now, I am running on second generation i2, and my RAM is 12 gig. My hard disk 500 GB. I have improved or I have increased my storage capacity to 25 times. Still, I am saying I am really not sufficient. I'm really not satisfied with my storage capacity. I wanted to upgrade my system, my hard disk to something like 2 terabytes. I don't have any organization. I'm a individual user. Even though I'm saying I'm not, even though my storage capacity was increased to 25 number of times, I'm saying I'm not sufficient. I'm not satisfied. Then think from organization's point of view. If you say their data size has been grown up 100 times in the past 15 or 10 years, that is not a big issue. That is not a great thing we'll have to look into. That's obvious. If their data size is growing like that, so how can they actually organize their data? How can they organize their data from processing and storage point of view? On top of this processing and storage point of view, we have an issue called VVV. What is this VVV? Velocity, verbosity, and volume. That much volume of data with so much velocity, with so many types of data like structured, unstructured, semi-structured. So these three are my challenges: velocity, verbosity, and volume. Volume, I said, what is volume? Verbosity, types of data: structured, unstructured, semi-structured. Velocity, with how much speed you can actually do store the data or do process the data. With the three V's, our processing and storage complexities are anyways there. So do these permutations and combinations 3 into 2. 6 number of ways we had challenges in the industry. Even though your entrepreneurs are investing so much amount of money with your data warehousing, still we had so many number of issues. That many number of complexities still industry is facing. On top of all these things, they are investing so much, still no satisfaction. That is the situation Yahoo Laboratory, the Yahoo concerned people are actually worried about. They started a project. At the time they were researching on this project, Google has produced a paper called Google's File System. That Google's File System paper was pretty similar to the project what Yahoo Laboratory people are doing. On top of this, Google has produced another paper called MapReduce. With that inspiration, they have merged the file system which they are already doing research with the MapReduce and finally found out a software called Hadoop. This Hadoop can take care of storage problem, whatever we had. The data size is going to gigabytes, no problem. You can happily store the data. And HDFS is the component Hadoop distributed file system. Can take care of organization of your data from storage point of view without any issues. Whatever the complexities, 3 into 6 we have discussed. You can come from any point. HDFS is the answer from storage point of view. Processing that much amount of data which you store on HDFS. MapReduce is the answer. Together we used to call them as Hadoop. If you are going to install the Hadoop component on your system, HDFS and MapReduce are going to come by default. You don't need to explicitly install them. Yarn is the next version of MapReduce. We have some problems with MapReduce, so the next version with all the problems taken care, they have released another version, Hadoop 2. In that Hadoop 2, we used to call that MapReduce as Yarn in simple terms. So HDFS and Yarn are pretty common when you take the recent version of Hadoop. All the remaining components are ecosystems that I wrote here, like your pick, hive, scoop, HVAC, scoop, boost. All these components are explicit. Whenever you wanted, you will have to install them and you can work with them. These are the components which we are going to discuss in our course. Why I wrote Apache? Those people have found the Hadoop software in Yahoo laboratories, but later point of time, Apache Software Foundation has taken the patents of this Hadoop. That's why whatever the component that is going to evolve in the Hadoop platform will be patented under Apache Software Foundation. So Apache Pig is the software. It is I'll call them all them as softwares as of now. So for today. So Apache Pig is a software which is going to improve the productivity of a resource when you compare with MapReduce. Using MapReduce, you can process any data, any kind of data, any amount of data with so much speed. But you will have to write so many number of lines of code if you want to process with MapReduce. There, if you are going to use Pig, if it is feasible, then 50 lines of MapReduce code could be equal to 5 lines of Pig script. That way, the productivity of the resource has been taken care of. The productivity of resource has been increased using Pig component. So, whenever it is feasible, people are going to make use of Pig instead of MapReduce. Almost less than or equal to 20% of the industry are using Pig components, so we are going to discuss Pig. Before that, HDFS and MapReduce are the first chapters of textbook. So whenever I said first chapters of textbook, if you don't read them clearly, if you are going to jump to the next chapters, that really doesn't make sense. That's why we are going to discuss them in detail. Similarly, less than or equal to 20% of the people are using Pig, so Pig is also important. So I'm going to discuss Pig also clearly. Hive is the component. Hive is simply SQL on big data. So to learn Hive, obviously you need to have the knowledge on SQL. Most of the projects, like 60 to 80% of the projects which are actually happening in the current industry, are happening on Hive component alone. Hive is damn important component. I said damn. If you know Hive, you can survive in the Hadoop industry. Okay, I don't say you should not learn, or even though you don't know all other components, you can survive. I don't say that, but Hive has its own priority among all the other components. I am going to explain Hive like anything. I am going to explain Hive very in detail. Scoop, SQL plus Hadoop. If you have some data in your data warehousing in RDBMS system and you are migrating to Hadoop, let's say, in that case, you will have to get all the data which you stored on your third-party RDBMS system to Hadoop, nothing but to our HDFS, right? In that situation, using Scoop component, you are going to get all that RDBMS data from third-party RDBMS system to our HDFS using Scoop component. Most of the projects happening now are migration projects, so Scoop component is also damn important. We are going to discuss that as well very in depth. So all these five components are pretty important for us, so we are going to discuss them very clearly. Coming to HBase, Flume and Oozy, less than or equal to 10% of people. So together I am saying, if you ask independently for HBase, less than or equal to 10% people are using HBase component. Flume, less than 2% people are using Flume. Oozy, less than 5% people are using Oozy. So these are the widest user components, whatever I have shown here. So these components, HBase also, I'm going to explain you what is HBase, and some we are going to have a little hands-on on HBase shell, and I'm going to explain you how we are going to work with our HBase using Java API. I'm going to explain Flume component and its architecture with the help of a use case. Similarly for Oozy as well. To learn, I told you, so core components of Hadoop, HDFS and MapReduce. So all these concepts we have already discussed. So HBase is completely a NoSQL database, a data store. So what is NoSQL? Not only SQL. So we are going to discuss the NoSQL and RDBMS differences. And coming to Flume, that is a real-time data ingestion tool. We are going to make use of Twitter application to understand the Flume component. Next, Oozy is a data scheduling tool. If you are a working employee, you know what is data scheduling, what is job scheduling. Sorry, that's typo. So that should be a job scheduling tool. So amount of data, types of data, the complexities of our real data world are taken care using Hadoop component. So Hadoop is required. If 200 petabytes of data is being generated every day, that much amount of data you should have to maintain somewhere in the system. But none of the traditional computing techniques we had can actually take care that much amount, can actually take care that much amount of data from these complexities which are showing up. Then obviously on big data world, you will have to have Hadoop knowledge and you will have to implement Hadoop solution in your data world. So we are definitely gonna need Hadoop solution implemented in our big data world going ahead. Already people have started using it. We had so many number of projects actually happening with our Hadoop. I told you, people have started using it, and we need so many number of resources across the globe to work with Hadoop technologies, because Hadoop is a brand new course. People know this Hadoop course from 2009 onwards, and this is 2016. From 2013 as well, I believe, from 2013. So everyone come to know the word Hadoop. From 2009, only architects, that kind of people know Hadoop very well. But from 2013, so everyone in the industry came to know the word Hadoop. By end of my course, I'm going to, of course, we are going to do some classroom exercises, classroom discussions and all. Apart from that, by end of each and every component discussion, I am going to give a set of assignments along with my classroom exercises. If you are going to do those exercises or assignments, that will give you a lot of confidence. That lot of confidence, you know, if you have the confidence on a subject, you know what you can do, right? You can take yourself to the next level, whatever it is. The confidence actually matters. If you are sitting in front of interviewer, he always looks for your confidence in your eyes. When can you get your confidence? When you have a lot of hands on, you can get confidence. How you can get hands on? You will have to do your obviously hard work along with classroom exercises. So I am going to give you so many number of assignments, of course, for each and every component. At the end, I'm going to give you assignments. If you are going to do all those assignments, that confidence you'll get. With that help, you can take yourself to the next level. Once the course is completed, I'm going to give you some POCs. The POC is a proof of concept. That proof of concept is a kind of little project. In a single POC, initially you'll get the data. You are going to put the data in HDFS. From there, you are going to process the data using MapReduce. That MapReduce data will be output of that MapReduce data will be routed to your peak. Output of peak will be routed to Hive. There, using Scoop, you are going to export the data to some other MySQL or some kind of RDBMS system. Or this kind of life cycle you can understand in a single POC. Those kind of POCs, I'm going to give you a minimum of 5. Finally, real-time project explanation. This is not kind of a fake project explanation. So I'm going to, if you are already working employee, I'm going to listen all your roles and responsibilities there. So I'll help you to migrate your current project into Hadoop. There, I'll explain you what are the roles and responsibilities of as a Hadoop developer from your domain, your project. If the project is your working project, obviously, so if the person is going to ask you any questions regarding your project, as that is your current project, you can happily, with so much confidence, you can explain all the questions, whatever he is asking you, obviously. And on top of that, I'm going to explain some roles and responsibilities of that project. Obviously, the project related discussion in the interview will be completely taken care of. So that's how I'm going to explain all the components of Hadoop. That's my demonstration. Thank you guys.